much looking forward to the next paper because the title is very provocative. Innovation Insight, achieving specific energy consumption of 1 kilowatt-hour per meter cube with WeGen Red and forward osmosis integration. This is going to be presented by Mr. Kim Sun, CEO and founder of Medicine Planet. Really looking forward to your paper, Mr. Kim. Welcome to the stage. Please, can we welcome?
Thank you to the chairman.
The stage is yours.
Thank you. Hi, everyone. It's a great honor to be back on this stage. I was joining this MENA Desalination Conference last year and this year. And today, I want to introduce a quite stimulating title, 1 kilowatt of the desalination solution. Yes, I fully understand. However, we believe that we may achieve this number very soon. And please let me allow to start the presentation.
Oil has forever transformed the United Arab Emirates. It has enriched millions of lives, driving opportunity, progress, and prosperity across the nation. Yet as we look ahead to UAE Centennial 2071, another critical resource demands our focus: water. Like oil, water drives the Emirates' future, but the clean water that has sustained this progress comes with a cost. Each year, billions in wealth are funneled into subsidizing desalination efforts, which generate brine as a costly byproduct. Brine has long been discarded as waste, but what if it could be turned into a valuable resource? The Emirates' new oil. Brine contains a treasure trove of valuable minerals that belong to the people of the Emirates and should benefit them directly. Extracting these resources was once costly and harmful to the environment, but new innovative technologies now can transform brine into an opportunity. Medicine Energy introduces its patented brine management technology that extracts magnesium carbonate while capturing CO2. Minerals mined from brine have many uses in material manufacturing, such as in steel cables and aluminum sheets, helping to build an ecosystem of cleaner, greener materials. Medicine Energy will also explore calcium extraction from brine, seabed rock for CO2 sequestration, and hybrid systems combining forward osmosis and reverse electrodialysis to boost water production while increasing energy generation from concentrated brine and utilizing waste heat from industries such as power generation. By converting waste, like brine, into more valuable resources, Medicine Energy presents a sustainable environmental solution which complements the power and desalination industry, supporting both the Emirates' economy and the environment. The future of the United Arab Emirates isn't just in oil, it's in brine water and the endless possibilities it offers.
So you are seeing that the graph that the industry in desalination, mostly they demand on the RO market. And the SEC numbers, more likely, internationally, the average number is between 3.5 to 4 kilowatt, which is quite high numbers. And we are aware that the UAE and the Saudi Arabia achieve quite amazing number, which is below 3 kilowatt, but still we are having a barrier to break down the below 2.5. So earlier, as our Dr. Elian introduced, the agricultural market, they requires a lot of water, and there is tons of the brackish water as well. So we, Medicine, also have some information how we're going to approach this market later. So in Middle East, there are 4 major big players: Saudi Arabia, UAE, and Bahrain. Kuwait, those marketplace produce a lot of brine water, means that they demanding on the desalination industry. So let me introduce our product, RED. It's a reverse electrodialysis.
In a world where water scarcity is an escalating crisis, especially in the Middle East, enhancing existing technologies is crucial. Introducing WeGen, an innovative enhancement system by Medisun, designed to maximize the efficiency and benefits of traditional desalination facilities, paving the way for the future of sustainable water solutions. WeGen significantly enhances the efficiency and reduces the environmental impact of existing reverse osmosis desalination systems by reducing specific energy consumption by 30% and neutralizing harmful brine discharge. WeGen significantly improves the sustainability and cost-effectiveness of reverse osmosis desalination technologies. WeGen stands out by integrating salinity gradient power and reverse electrodialysis into existing reverse osmosis systems, providing unparalleled efficiency improvements. Unlike conventional methods, WeGen not only reduces the salinity level in seawater, but also generate electricity, helping to offset some energy consumed during the reverse osmosis process. Additionally, neutralizing the brine produced so it is safe to be released into the sea, protecting marine ecosystems while ensuring a consistent supply of fresh water with minimal environmental impact. In regions where water scarcity threatens entire communities, WeGen's mission is to ensure sustainable water management solutions. Our vision is clear: a world where clean water is accessible to all, guided by the principle.
All right. So if I go for the key point, our RED actually utilizes two different of the liquid. One is the salty water, and the other water would be the lower salinity. So our selective ion exchange membrane can separate the two ions. One is a plus and one is a minus side. So when you see the whole diagram, you can simply think about the AA battery. So one side is plus and one side is minus, which means we generate DC power through the brine water, I would say. So conventional RO systems, more likely the highest power consumption happening from the high pressure pump. So in this flow chart, we're adding a 2 RED, and one is a WeGen green, which is a magnesium the extraction systems. So the first RED, what you're gonna do is, it's gonna dilute the salinity of the seawater before we inject into the RO pump, RO systems. So as much as we reduce down the salinity, the high pressure pump requires a less energy consumption. So this is where we're gonna have the highest energy saving, which is around 30%. And same time, this process, we can generate electricity. And all this electricity that we generate, we're gonna feed back into the RO systems. So after the RO system produce the clean water, and then now we're seeing the brine water. Usually, this brine water, we discharging to the sea because there was not much solution to manage. However, our system, which we call WeGen Green, we're using this brine water as a source of the mineral warehouse. As you understand that the sea water has tons of rare minerals inside. So we focus on to extract the magnesium first and calcium. So these two minerals will be extracted, and during the process, what will happen is we can extract from 1 ton of the brine water, 8 kilograms of the magnesium carbonate, and same time, we can capture down the 3 kilograms of the carbon dioxide. So when we think about the normal RO desalination plant, they're gonna produce around 1.6 to 1.8 kilogram of the CO2 from 1 ton of the fresh water producing. And then after our WeGen Green produce the magnesium and the calcium, we're gonna inject this brine water into the second RED. And the second RED gonna generate much higher energy. And this will be also feedback into the RO systems. So when we talk about total systems, we give around 30% energy saving from the existing your power consumption. And same time, we can neutralize the brine water. And also we can take it out bypass product, which is a magnesium carbonate. So this package is for the RO system, and I'm going to introduce another system soon. So now we are going to talk about a FO. I understand most of people understand the FO, there's a limitation. However, I will introduce how we're gonna approach with our RED with the FO systems. So when you compare with the RO and FO, usually normal RO has a limitation from the salinity. They are not able to utilize this RO membrane if the water source has above 50,000 TDS. However, our FO, it doesn't have a limit. I would say over 20%, 25% still we can manage. And it has a minimal fouling, and also we use a lower the pressures as well. And more likely, we have a highest recovery rate. In Middle East, normal RO plant, they can go up around 40%, maybe maximum 45% recovery. However, our system, I will introduce it very soon, it goes up to around 90%. So this flow chart introduces the demonstration how we're going to use the system. So let's say the left side, this is seawater, no more 4.3% of the seawater feed in, and we're going to do the pre-treatment. And the first FO system going to take it out 65% of the fresh water. And this 65%, after we take it out, the brine water going to be remaining 350 tons, and the salinity goes up to 7.1% from 4.3. And then we're going to inject this water into the VGN green, and we take it out magnesium and calcium. And after that, we inject into second FO. And this second FO, we can maximize the recovery rate to be 90%. So in total, the total freshwater generation is around above 900 tons from 1,000 injection. So what will happen after second FO, the brine water will goes into our RED stack. And our RED stacks, we're gonna generate much higher energy generation, and we feed back the remaining water into our second FO. So more likely, this is very close to the GLD system, but I would say VGLD, very minimal liquid discharge, because the brine water will be injected into the second FO to squeeze out more fresh water. I think we have a limited time here, so let me skip some file. So all this fancy system can be happen only if we can utilize the waste heat. The waste heat, actually, when you see the RO desalination plant, most of the RO desalination plant, they have on their power generation system, power plant. And this power plant, usually they generate tons of the waste heat. And that waste heat temperature goes up to around, goes up to around 1,000 to 500, 1,000 Celsius, which is pretty good enough to utilize all the FO. And more likely, the market focus on the renewable energy to adopting the PV or the thermal systems. And also, I believe RO industry already saturated. The manufacturer side, they are fighting against the to minimize the cost. And the efficiency more like is saturated. So, while we are investing on to make a more novel products, novel membranes in RO, I think we also change our point of view, sweep into the waste energy utilization. Why we don't use the waste heat around? There's tons of waste heat. So I was coming up with the idea that we're gonna utilize the waste heat, which we can utilize easily, and bring into the FO. Then in total generation, if RO desalination consumes 3.5 kilowatt for 1 ton of fresh water, FO can goes down to around 1 kilowatt. Yes, but still we need a waste heat. However, we believe that we can source this waste heat from the power plant or from the bottler like a Pepsi or Coca-Cola or Red Bull. They have tons of the waste heat. So we can utilize those remaining heats. And I think we have a limited time, right? And thank you very much, everyone. And hope we have more time to talk about outside. Our booth is 9, so visit anytime if you have a time later.